Still on partial fractions. Today we'll be talking about repeated factors at the denominator. So look at this. These factors are repeating themselves. So I can write this to be 3x minus 4, x plus 2, and then x plus 2. You see why they are repeated factors. Now, if you use cover-up method for this system, you fail. Or you can use direct substitution, comparing of coefficient, or identity method. Now, but there is a technique I want to show you in this video that is called algebraic substitution. Most of you may not have seen it before. It's not in your regular textbook. Okay, so what does that entail? I'm going to substitute this denominator. I'll set it to u. U will be x plus 2. So I'm going to make x the subject. So my x now will be u minus 2. So wherever I see u minus 2, wherever I see x, I will substitute u minus 2. So I'm going to have 3 bracket u minus 2 minus 4 over over u minus 2 plus 2 or squared. So I'm going to have a 3u minus 6, right? Then minus 4 over, the whole of this will give me 0, so I'm going to have u squared. So this will be 3u minus 10 over u squared. So I can break the fractions down as follows. I'm going to have 3u over u squared minus 10 over u squared. So my u will take down this u. So I'm going to have 3 over u minus 10 over u squared. So what is my u? My u is x plus 2. So this will be 3 over x plus 2 minus 10 over x plus 2 squared. So this is the partial fraction of this. So this is called algebraic shifting or algebraic substitution. So please save this video and take note of this. I'll do more examples on this type of problem.